Welcome for the last day. We're kind of the caboose for the conference. And I wanted to thank ARC for inviting me. And I always start off by saying my watch says it's 5:36 in the morning. So that's my excuse if anybody has a problem. Let me see. One of the things I also like to do is start off with the title of my book, because it kind of explains what's going on and why we're here. It says protecting. Hacking control systems is not difficult. Protecting them is rocket science. You'll notice it says industrial control systems. It does not say SCADA. What we're talking about is basically, DCS, SCADA, PLCs, RTUs, sensors, actuators, drives, you name it. It is not this term, and whenever anybody uses the term SCADA security, I tell people run the other way. That's somebody who has no idea what we're talking about in the world of control systems security. And the other point is it says electronic threats. It does not say hacking. And I'm going to go through that because I'm going to go through what is the definition of a cyber incident, because that's very important and it's different. Okay, real quick, I've been doing this for a long time. I'm a control system engineer that got into security. I have patents on things like fuzzy logic turbine controllers and optical strain sensors. Not exactly what you expect to find in the security world. And I've also amassed, without meaning to, a database of well over 1,000 actual control system cyber incidents, and I'll go through that a little bit. This is real. There's been more than 1,000 deaths to date. So when you start talking about this, it's not hypothetical at all. Now, we're going to start with the Purdue reference model. In fact, I wanted to also go through one other point, which is basically, 0-1 from the reference model. You'll notice it's where you have process I/O devices, basic control devices, etc. But for people who are not aware, the Purdue reference model was originally set up and the classes defined based on time. So 0 was real time to microseconds. Level 1 was microseconds to milliseconds. 2 was milliseconds to minutes, seconds to minutes. And then as you're going up, so what you're looking at is the most critical, and where safety is where you have to respond instantaneously. The operator isn't involved when you're in the world of microseconds or milliseconds. So effectively what's happened, there's two things, and that's why ISA 99 has a new working group of people who are interested on what do we do about level 0-1 devices. But what you'll see is it's all the way down there. And there's another point here also. And it also goes a little bit to where Larry's coming from. When you look at 0-1, and part of our problem is depending on where you go on the internet, 0 may say it's only the process, 0 may say it's the process, sensors, actuators, and drives, okay? But the issue is that it's been excluded from the world of cybersecurity. And part of the reason for that is that security, and this is what you've heard throughout the conference, but is going to differ here. Everything else you've heard is security has been the network. And the devices have not been part of the discussion of cybersecurity because it's not part of the network. This is part of where we're going from. You look at our major vendors. All of them are spending millions and millions and millions, tens of millions, on trying to secure the network. To this day, none of our vendors, none of our major vendors, have security or any security requirements for level 0 and 1 devices. because it's not part of the network. Again, what happened in Texas, 2 weeks ago, I gave the keynote at the Texas A&M Instrumentation and Automation Symposium. That's the control and safety engineers. And what was fascinating was on the 24th, the day before I gave my keynote, they had, like you had here, you had all of the vendors with their displays. And there were 3 major sensor vendors with all of the sensors sitting on the tables right next to each other. And I asked them, or told them, we have this new working group on 01. What are you doing about the cybersecurity of your sensors? And you know what the answer was? January 24th, 2018, nobody's ever asked. January 24th, 2018. Now, what was more, one of those vendors had a safety PLC sitting on the table. And they go, that's got security. How much security can there be when the sensors, which are providing the input into the SIS PLC, has no security? And the response was dead silence. When you talk about safety, that's here. Now, the other point, and it goes again to Larry's slide. When you start talking about sensors, and that's what the Purdue reference model called it, sensors. In the 90s, sensors were 4 to 20 milliamp dumb sensors, okay? Well, today a sensor can be a 4 to 20 milliamp dumb device. It could be a 4 to 20 milliamp device running HART. It's really an analog device, and you've basically superimposed digital on top of it. Or it could be running Profibus, Fieldbus, etc. Or it can be a fully smart, integrated sensor or transmitter, which is essentially a mini PLC. So when you start looking at this, it doesn't make sense anymore. This is part of what we're trying to do, is how do we redefine what 01 is? Because it isn't what we originally looked at in today's environment. Not only that, you've got vendors who have integrated, for example, flow controllers, where the sensor is part of the flow control system. And now you start saying, if that's operating in milliseconds, or microseconds actually, where does it sit? These are issues we really haven't discussed. What I want to do is get people to understand what we're really talking about when we say 01. This is the only real connection to safety when you start talking about security. And we need to also, this is no longer a security discussion, it's an integrated security and safety discussion. And that's what's going to flow into Dave's presentation, and it's also going to flow into what Ben's saying as we go into the Triconics piece. But the point being, this has to become part of the discussion, and it isn't. 01 devices. Like I say, I've already gone through most of this. And, you know, part of what happened, history, was prior to 9/11, the operators owned everything about our control systems. Following 9/11, cyber was considered to be national security, and it was moved from the operators of the equipment over to IT. And since that time, cyber has been the network. And this has essentially been orphaned from the world of security. And it's also kind of leads back to, quote unquote, the de facto definition of a cyber incident or security. In the IT world, the de facto definition is you're connected to the internet, you're running a Windows system, and somebody's trying to manipulate your data. The NIST and Presidential Policy Directive 41 definition of a cyber incident is simply electronic communication between systems that affects confidentiality, integrity, or availability. Okay? Not one single word about malicious in that definition. Okay? The other thing is, it's an IT definition. Our most important letter isn't even in there. It's the letter S, safety. Why? IT can't kill anybody, we can. So when you start talking about this definition, it's very different. One of the other points, and I found this when I was at Microsoft had an IoT conference in San Jose last year. And they basically said the cloud assumes that the sensors are authenticated and secure. What does that mean to the world of industrial control systems? The cloud is built on quicksand. Why? Because none of our process sensors are either authenticated or secure. It's an interesting thought or concept, isn't it? And I'll show you, in 2016, ICS CERT put out their list of all of the cyber incidents. It only went down to level 3. ICS CERT has never really done anything at level 0 or 1. The CSET tool coming out of Idaho has nothing in there for 0, 1. One of the unintended consequences of all of this is, and I'll go through it in a minute, but it's really the conversion of the analog signals or the analog control to digital and Ethernet, really to Ethernet in order to get it to that Windows HMI. In the world of engineering, what we've always worked with is process noise. What's going on with the sensor? What's going on with the process? The unintended consequence of all of this is that's all been filtered out. So what it's saying is all of the network-based anomaly detection, network-based everything can't, oops, let me go back. Oops, sorry. Where is the, oh, okay. That's where I was. But can you see on the right, in other words, this noise, that's what would tell you, for example, is a sensing line clogging. You know, do you have flow-induced vibration? All of this stuff that an engineer would look at to say, what's going on with the process? Every bit of that has been filtered out. So when you do anomaly detection from the network, you cannot correlate that back to what's happening, sensors or the actual process. It was the unintended consequences of what was going on. And what makes it worse is the serial to Ethernet converters, your gateways, and start thinking about this for IoT or IIoT, et cetera, are one of the more cyber vulnerable aspects we have. That's what was compromised in the Ukraine. It's also what was compromised to put black energy in our electric grids all the way back in 2014. It's not hypothetical. Now, the things about sensors. First of all, like with a smart sensor, the smart sensor requires two-way communication. You can't use a diode. It requires two-way communication. Smart sensor has two masters. This is a reliability as well as a security problem. The simplest thing to do, you take a handheld communicator, you change the sensor ID, the PLC, SCADA, or DCS master station can no longer see the sensor. You just did loss of safety. And there's really no way of knowing, was it malicious or unintentional? The sensor protocols. People keep talking about, Modbus, DNP, et cetera. We're a level below there. We're talking HART, Profibus, Fieldbus. The co-chair of my committee His doctoral thesis was on hacking wired heart process sensors. The next cohort going through the Air Force Institute of Technology is getting his doctorate. His dissertation is on hacking wireless heart process sensors and actuators. None of this is hypothetical. And the other point is that, in fact, one of the things I've got, it's an eye test, so you won't see it. But January 23rd, ICS CERT put out another vulnerability advisory on, Profinet. Anybody who thinks that's not vulnerable, okay? And our sensor standards, it's the flip. The sensor standards don't address security, and our security standards don't address the sensors. When I say sensors, I'm lumping that in as level 01. That's the gap. I mentioned the serial to Ethernet converters, and how they've already been compromised. I mentioned this, that the other point I wanted to get across, and it occurred here I was here all day yesterday, I'd missed Monday and Tuesday. But people make an assumption that you're going to know what a cyber attack is. And when you start getting down toward 01 and others, in general, you're not going to know whether it's cyber or a process upset. They will look the same. What's important is to know, is the system doing something off normal? But there is, again, this assumption, just like on what's a cyber incident, there is this assumption that if it's a cyber attack, you'll know it. Part of the thing is, like I say, I have a database of over 1,000 actual control system cyber incidents. The vast majority were never identified as being cyber. And this is just the fact that they've occurred in all industry. Starting from the top left, that's complete destruction of a turbine, that's Aurora, that's the DC Metro train crash, San Bruno natural gas pipeline rupture, Bellingham, that's the Olympic pipeline rupture, Marucci was opening sewage discharge valves and dumping 1 million liters of sewage, tilting an offshore oil platform. That was in Russia, that was lifting a 1,000-ton turbine off its pedestal. That was complete destruction of a 6,400 megawatt hydro facility, killing 75. And the last is a brand new Navy ship that couldn't even make its maiden voyage. It had to be towed in the last 40 miles into Norfolk. This is not anything that's in just one industry. And people keep talking. There's a whole thing right now about Shodan and what's connected to the internet. There's more than 2 million ICS devices currently connected directly to the internet. And the last part is really, really, really important. In our world, we can't really prevent a cyber event. We haven't done near enough about what do we do about resilience and recovery. Bellingham. And this gets to be kind of interesting because I sat in on, I think it was Steve's from DuPont gave a presentation yesterday, and we was talking about the big oil storage disaster in the UK and what also happened in Puerto Rico. Those were control system cyber incidents. But he was saying, gee, nobody's been killed. Well, yes, they have. This is Bellingham. This occurred in June '99. This one is important because this is the first case where you've had a cyber event that led directly to loss of safety. Everything else you've heard has been trying to wave around why safety is important. In this case, and I did the analysis for NIST, everything we had was provided to us by NTSB. But what you had was a SCADA system that had a 3 to 7 second scan rate. Right before the accident, it went from 3 to 7 seconds to 30 seconds to 400 seconds to totally unresponsive. So they had complete loss of view and control before the pipe broke. But then what they also did, their logic was if SCADA were to go dark, they set all of their sensors to average values. And you can all say, why would they do that? They did it. No amount of monitoring was going to find a problem because the sensors were set to average. But by doing that, they created a loss of safety condition because the sensors could no longer reach a set point. And start thinking about that as you start thinking about or hear later, the Trice's case, even though it wasn't there, but what you're really doing. If you really want to prevent, loss of safety, you simply go to the sensors, change span or range, and the sensors can no longer reach a set point. You have loss of safety. Why are they important? I think I've gone through all of this. We also have minimal forensics. So if you start changing things like span range or damping, there's no forensics. The sensor seems to be responding, or it's sending data so fast you will brick a PLC and not know it. This is, again, when people talk about safety and security, I wanted to explain why they're different and why we have this problem. You look at the top, a safety system, whether it's in oil, gas, petrochem, nuclear, it doesn't matter. You have a sensor, you have a logic solver, which is a PLC, if you will, and you have a final element. Well, that's what a safety system is from a safety perspective. From a security perspective, think about it. An analog 4 to 20 milliamp sensor going to an analog logic solver going to a mechanical or hydraulic end device compared to a smart transmitter directly connected to the internet with a Windows-based logic solver going to an actuator that's got a web interface. You couldn't be more different when you come to security, but from safety, they're identical. This is part of the reason we haven't gotten safety and security on the same page. This is, I think, my last slide, but what I wanted to get across, this is NAMOR 163 and the safety design, and one of the big things here is the fact that all of our safety standards allow, they may want to discourage, but allow basic process control to be integrated with safety. And what you're going to hear from the Tricon situation, we cannot do that anymore. What's interesting here is, again, one of the things that's out there, you heard how vulnerable our serial to Ethernet converters are. Yet, that's what you need in order to go to an HMI, a Windows-based or any other based HMI. To have that going to SIS and think that you're not making SIS, first of all, connected to the basic process control or elsewhere is foolish. We've got to rethink that. And it's okay to do that if it's isolated. In the nuclear industry, by regulation, you cannot mix control and safety, period. By regulation. We've got to go that direction here. This is the last slide. This is what do we need to consider? And think about IoT and IIoT. Where does it start? Okay, people are worried about Raspberry Pis and all of these little, $20 or $50 sensors. Our $500 and $1,000 sensors we use in safety have no security in them. I told you we've got a new working group. If people are interested, let me know. But one of the things we just we had a call last Thursday, and one of the outcomes was that for all of these legacy 01 devices, the 62443 standards simply don't apply. You can't fit security into these type of devices. So the recommendation that's going back to the 9905 leadership group is we're going to have a standard. We're going to need two. One for the legacy devices of how best do you isolate them because you can't secure them. The other is moving forward, what should be the requirements for new 01 devices to have adequate security. And again, all of this has to couple into what's also going on in safety. The last piece is often neglected. It's kind of a NIST thing. You know, if you can't do something, you have compensating controls if you don't have the technology. We really need to understand what are the appropriate policies, procedures, and what are the procurement specs? You know, when you say I want a secure system, what does that mean? So that's really what I wanted to do, is give you kind of an intro. Where are we? What does this mean? And I want to now turn it over to Dave to have him talk about what's going on from, if you will, the field.